Okay, so let's look at problem 12. Okay, we went over this a little bit in class today. And I want you to think about, well, whatever g of x is, I got to plug it in. I'm sorry, I'm looking at 12a. I got to plug it in right here. And when I plug it in right there, it's got to equal that. Well, hopefully this one you can just kind of see, okay, it has to be x squared. Because if I plugged x squared in for x, bam, that's what I'm going to get out. Okay, this one was a little bit more complicated. I know that I have to plug g of x in for x, and what's going to come out is x. So I'm just going to do that. I know if I plug g of x in there, I'm going to get x. So I got to solve for g of x because that's what I want to know. So I'm going to subtract 1 from both sides. So 1 over g of x is x minus 1. Now, we could cross multiply and we could do all that, but there's this nice little trick that says, oh, if you have a fraction equals a fraction, the reciprocals would be equal to each other as well. So the reciprocal of this is g over x. The reciprocal of this is that. Okay, so kind of a nice little trick to remember that if two fractions are equal, their reciprocals are equal. It just saves you a lot of time. Okay, so now when I got to C here, I kind of tried that idea that we did in B. It didn't work. It's not going to work. And so I really had to sit and look at this for a while because I couldn't figure out, I could come up with the answer, but I was trying to figure out, like, well, why does it work? Because remember, that's the thing that's our goal. So after sitting there for a while, one of the things that I remembered is that if a composite function is equal to x, this tells me that f and g must be inverses of each other. And I don't know if I would have expected you to remember that, but that was a way that we proved that things were inverses. We showed that f of g of x was equal to x and g of f of x was equal to x. Okay, so if they're inverses of each other, then f of x would just have to be the inverse of g of x. Okay, so let's look at how we figure that out. Well, okay, we know that g of x is 1 over x. So that tells me it looks like this. Okay, the inverse, remember we switch x and y. Okay, so that's the inverse. But we don't want the inverse in terms, or solved for x, we want it solved for y. So I'm going to cross multiply. X times y equals 1. And then I'm going to solve for y. Okay, so this is the inverse. This is the inverse solved for y. And we said, oh, okay, f and g are inverses of each other. So f of x must equal, I'm not going to put that, 1 over x. Okay, now, it seems kind of sketchy. Let's try it. So if I plug g of x, okay, so if f of x is 1 over x, and g of x is 1 over x. Well, let's do f of g of x. So that's 1 over, and plug that right in there, 1 over x. Oops. Now you might be going, oh, ouch, that hurts my brain. Okay, this is 1 divided by 1 over x. Now remember, that's the same thing is multiplying by the reciprocal. Yeah, so it works. F of g of x is equal to x. So there's our answer. Okay, so again, this is why I told you that you guys, your SAT scores will just go up hugely because we just start reviewing all of these things. Okay, so here's another case that, that I know that these have to be inverses of each other. Now, the problem, I got this from your book or something like that. I'm not seeing that we have to have absolute value bars on there. And let's look at why. Okay, so if g of x is equal to the square root of x, and let's do the same thing again. Let's say, well, they're inverses of each other. Okay, so I know that y is the square root of x. Okay, so the inverse would be x is the square root of y. And then I want to solve it for y, so I would have to square both sides. And f of x would have to equal x squared. Now, if you're wondering, what's up with that absolute value of x thing? Okay, I'm going to show you, like, you either have to have one or the other. So I'm going to show you that. Let's look at f of g of x to make sure it works. So I got to plug in the square root of x for x. So it's going to look like that. Well, the square root of x squared is equal to x. Now, here's the caveat. It wouldn't be equal to x if x is a negative number. So we would have to say it's equal to the absolute value of x. But since we said, you know what, you can't take the square root of a negative number, we just said we're only working in the real number system. So as long as we say x has to be a positive number, then the square root of x squared would equal x. So I'm going to say you didn't really need, you needed one or the other on here. Don't worry too much about the absolute value thing right now, you guys. That's not that important. As long as you kind of understand that it would have to be x squared. Hope that helps.